Thank you so much for coming. This is so lovely. Welcome to day 2. So my name is Jo, and I am a DevRel at Deno, and today I'm going to talk you through building an in-browser code editor that not only runs in your browser, but also lets you safely execute other people's code. But before we get started, I'd just like to ask you a couple of questions. Like, first of all, who here has actually heard of Deno before? OK, that's a good amount. And who's actually used it before? OK, smaller. And is anybody actually using it in production? No. OK, well, that's cool. So today we're going to be building with Deno, and hopefully I can introduce you to some things that you might love, some things you might not know. But let's get started and dive in and build an editor. But first of all, why might we want to build an in-browser code editor? So aside from being a kind of cool project, there are many reasons why you might want to build one of these. If you work at a company that offers APIs or other tools to developers, it's a great way of improving your onboarding experience if they can try out the code right in the browser. It allows you to let developers try out your code immediately without needing to set up their own local environment. And things like embedded editors within your documentation is really nice for helping people learn how to use your code immediately. No need to switch between tabs or get out their IDE. They can just try it out. And an in-browser editor can be really helpful if you're offering a low or no-code solution. And I know we say no code, but there's occasionally times when you need to add a bit of extra functionality into that no-code solution, and just having a box where you can type in some code and execute it is really useful without needing to, change product. But running code that other people have written presents us with a problem. We can't trust code to execute on our machines, on our websites, that other people are going to write. We just don't know what they're going to write. Allowing third-party code execution can introduce us to a whole load of security vulnerabilities. There could be malicious scripts trying to steal our data. They could be trying to inject harmful code into our websites or compromise our users' data privacy. So we need to try and prevent malicious code from wreaking havoc on our own code bases. Not only that, but we will need to provide resources which are going to run this code. We need CPU, we need memory. These things could potentially impact the page load times for our own site. So in order to make an in-browser code editor that's going to run third-party code, we're likely going to end up needing to provision some sort of compute, a large amount of compute. We're going to need to perhaps install something like Kubernetes on it. Then we're going to need some management APIs to make sure that only the correct shape of code gets executed. We'll need to make sure that our container instances are secure, and we'll need to make sure that we don't run out of storage. And likely, we're going to need an entire ops team to run this entire thing. The truth is, building a managed runtime is we're talking like millions of dollars worth of problem here, which is a pretty significant barrier to entry for most people who just want to make something cool and interactive and build fun experiences on the web. So with all of this in mind, how are we going to build this editor, and what are we going to need in order to do so? So first of all, we're going to need an app of some kind, obviously. Something like, imagine like CodePen or JS bin. So we're thinking like a text box where people can type in code, and a go button where they can press go and execute the code. Then we're going to need some sort of hosting, which is going to run this app so that people can actually visit it and see it. And finally, we're going to need an application platform that is going to actually run the user's code. So probably something like serverless functions. And I work for Deno, as I mentioned, and we have products that solve all of these hard problems for you. But what is Deno? We are an open source JavaScript runtime for the modern web. We're built on web standards, built in Rust, so it's super fast, using V8, which you will already know if you've ever made a Node project. Deno natively supports TypeScript out the box. So you can just run your TypeScript code. You don't need an extra config setup. You don't need to install anything else. you can write strongly typed code immediately and catch errors early. And Deno also has tools for formatting, for linting, for testing, and it just really sort of streamlines your development flow. You don't need to install anything else. And you might have heard of us because we've been around for a few years. Deno was actually built by the guy who originally built Node, Ryan Dahl. And he gave a very famous talk at JSConf about 5 or so years ago with like 10 things that he learned about building Node. So he took all of this experience from building Node and tried to build something that was better, that was a more delightful developer experience. And the whole hope that he had with Deno is that it would level up the JavaScript ecosystem by narrowing the gap between the browser and the server side, and obviously allowing TypeScript to be a first-class citizen. So Deno works out of the box with all of the modern web tools that you're used to using. So we're going to be building this with React, with Feet, with TypeScript. And you might be wondering why, why would I want to add Deno into the mix here? And the answer is this. Not only is Deno great for running TypeScript code and running it super fast, Deno is faster than Node. It's complemented by all the other tooling that Deno has. And it makes building things like this just a very pleasant experience. So I mentioned we're going to need some sort of hosting. Deno has Deno Deploy, which is Deno's hosting solution. If you've used Heroku or similar before, it's very similar to that. It's a worldwide platform. It's great for server-side JavaScript and TypeScript hosting. And it's powered by the Deno runtime, run on very efficient V8 engines. So it's super fast, super lightweight, really nice and easy to use. And Deno also has, so I mentioned we're going to need some sort of serverless functions. Deno also has our serverless functions for us. So Deno has this thing called subhosting, which is a set of capabilities that are built on top of deploy, which are designed for securely running code written by multiple people in a sandboxed environment. It supports JavaScript, it supports TypeScript, and it's optimized for super fast deployment and cold start times, which is exactly what we need for this scenario. We've got a load of really nice APIs, so it's very easy to deploy your code immediately. It supports global deployment, it's low latency, we can access it from everywhere in the world. And I don't want to stand here and do a giant sales pitch, but the cool thing about subhosting is it's built for developers, it's built for tool builders, people like yourselves, to allow you to offer serverless functions to your own customers without having to worry about infrastructure or scalability or anything like that yourselves. So, with all of this in mind, let's actually build the app. So first of all, we're going to set up a new Deno project. Setting up is super easy. You can install Deno with curl, with brew, with chocolatey, depending on what operating system you're on. And if you've used Deno in the past, a lot of things have changed. So it's probably more familiar than you think if you're moving over from Node. So the first thing we're going to do, we're going to init a new project. Much like creating a new Node package with npm init, Deno init is going to just create a basic project for you. It's going to give you a TypeScript entry point, a config file, and a test file. So let's take just a really quick look at them. So this is what it's going to create for you. You can see in here you've got your main TS, your main test, and your Deno JSON. So we've got our basic entry point. And let's take a look at the JSON. So this is your config file where you can configure how you want Deno to run. It's where you're going to set up tasks. Tasks are very similar to Node scripts. So this is all stuff that you should have seen before. This is where you can also manage and import your dependencies. And incidentally, if you are working with the Node project, you can keep your package JSON. You don't necessarily need a Deno JSON. It's just there if you want to configure the extra tools that Deno has. So if you want to add linting rules into the linter or add formatting rules into the formatter, this is there for you. And finally, as I mentioned, we have our testing file. Deno really cares about writing good tests and making testing super easy for you. So there's a testing runner built into Deno that runs out the box. So that is your sort of 60-second intro to your Deno project. Now we're going to actually configure a repository that works with Vite, that works with React, so we can actually do some web dev. So let's edit that default project that we just made. We are going to, if you want to run the default project, you can do it with Deno task dev, and if you want to run the tests, you can do it with Deno test. So we're going to add some dependencies. So I mentioned we want to use Vite for our local dev server. We want to use React to build the actual UI with. So we're just going to add all these dependencies. We can do it with Deno add, very similar to how you've worked with NPM before, and that's going to add those dependencies into your Deno JSON. And then we can create a task, which is going to start up our Vite server. So let's take a look at our updated Deno JSON, which is going to look like this now. So you can see we've got that extra task in there, and we've got our new dependencies. So in order to run this thing, you'll see there in our Vite start task, we've got Deno run -a. That -a is a permissions setting. So by default, Deno tries to be more secure than Node. So it will deny access to things like network, to files, to environment variables, and you need to explicitly allow these permissions. You can do so. There's a bunch of allow tags, so you can allow net, allow file write, allow read, that kind of thing. Or you can use -a, which is allow everything. We don't recommend that you use -a in your real projects, but for building a little task thing like this, it's just quicker and easier. So we're going to use -a. And then one of the cool things about Deno is it manages your dependencies directly. So what it does is it doesn't create a Node modules file like you might expect in Node. It doesn't cache the packages in your local working directory. Instead, it caches them in temporary storage, which makes your development experience just a little bit neater. You don't have that ugly folder with all those files right there in your working directory. And it makes your developer experience just a little bit faster. So let's build our app now. We're going to need to make a folder where we're going to put our app and a folder where we're going to put our backend. So I'm going to make a client directory folder, and I'm going to make a server directory. So my new, have I got them in there? No, you can't see them in there, that's fine. So inside of the root directory, we're going to also need to configure our Vite project. So we're going to just make this Vite config file, and what that's going to do is make sure that we're looking at our client directory, which is where we're going to actually build this app. So we've just got root/client there. And then when we run Deno task Vite start, Vite is going to get executed by Deno and be ready to host whatever app we put into that client directory. For the sake of brevity now, I'm not going to show you how to build a Hello World React app or a Hello World Vite app. This is all beautifully documented on the web. I'm sure it's something you've all done many, many times before. But what you're going to do in that client app is, set up your Hello World Vite app, your Hello World React app. You can literally use create React app inside that directory if you want to. But what we'll do for now is you'll need an index.html and an index.ts file inside of that client directory just to get started. So let's talk about the app that we're going to actually build on top of our Hello World. So once you've got that all set up, once you set up your Hello World, this is what your directory structure will look like. So we've got that client directory with our app inside it, and at the moment our server directory is empty. So what are we going to build? We're going to build a super basic little UI. It's got a text area where users are going to type in the code. This is not going to be beautifully styled. There are a bunch of libraries out there that can do things like syntax highlighting and things like that on code editors for you. I'm not going to talk about that today. We're just going to talk about the functionality of it. So this is going to be not the most beautiful thing you've ever seen. But this is what we're going to make. We're going to have an area where we can display the output of the code that they run, and then we're going to write some API functionality to actually create these code boxes when people actually choose to run some code. And this is what it's going to look like. So remember, I talked about the subhosting API earlier. That allows us to run untrusted code and return an output. We're going to write a backend API that is going to call Deno Subhosting. It's going to create a new project. It's going to run the code in that project. And then it's going to return the results so that we can show them in our UI. And we're going to use React Router. We're going to make a single-page app. And this is going to be the component that presents the text area to us. So if you take a look here, you can see we've got a text area where the user can type in their code. Underneath that, we've got a button where they can run. And then I've got this deployment viewer component, which is just the place where we've got an iframe, which is going to show the instance of the running code sample that they have just run. So let's take a look then. Let's expand this file out a bit. So inside here, we've just got a few state variables, which are actually going to make this component reactive. So we can see where we can set the URL of that iframe. We can set a status on the button that says, like, we're running right now, that kind of thing. And we can update the actual code. The most important part of this document is our deploy changes function. So when our user clicks on the run button to deploy their changes, we're going to call our backend API. And this API is going to interact with the Deno Subhosting API to take a copy of that code, host it in a brand new running function, and then each subhosted function is going to have its own URL. And the deployment viewer is what's going to display the content that is at that URL. Another thing of interest in this app is our API client, which is responsible for all of the fetch requests that we're going to be doing. And there's a few functions in here. So first of all, we have the loading sample code, which is here. Just in case when the user comes to the page, we don't want them to try and run nothing. So we're just going to give them a bit of sample code that they can run on their first landing of the page. Then we have this deploy project function, which is responsible for both creating and updating the code sandboxes. Then we have our wait for deployment function, which is what we're going to use to poll to see if the running function is ready to show yet. And we have this wait for deployment function, which is going to just get the deployment API. But we've not built out any of these APIs yet, so let's do that now. So when we deploy this application, we're going to need to have something to host it first, because at the moment, we've just got Vite doing that job for us locally. So to make sure Vite and the backend APIs play nicely together, we're going to have to add a couple more tasks into our Deno JSON that we'll then use during the CI. So we're going to create a Deno server-side app that we can deploy, which is actually going to host our React app when we are using it in the deployed version. So we're going to create this new task here, which is server start. We're going to move that main TS file that got created when we did our Deno init into our server directory, sorry. And then we can start editing in there. So what happens is when we deploy the project, we'll use this Deno server-side app to host our backend API so that React can then call it. So let's update that main TS file now that we've just moved into the server directory. So this is the entry point for our server-side backend API. This file uses a web framework called Oak, which is going to do just some basic URL routing. And you can see here, this is kind of one of the cool things about Deno. You can directly import packages as well as importing them through Deno JSON. So you can see in here, we're actually directly importing the Oak package from JSR. JSR is just a modern package registry for ES modules. So if you're writing modern JavaScript, check out JSR. And Deno can resolve those packages at runtime when the script executes, which is going to be super helpful for us later when we might want to run these things inside our serverless functions. So in this file, we're just initializing Oak. We're asking it to route some static files from client dist inside of our current working directory. And this is the location that Vite is going to use to compile the static assets of our React app. So when we run this app, after we've compiled the React app, it's going to act as a web server, and it's going to serve the React app that we've just made. We've already set up our Vite config to proxy to /API and back to this server. And just what all of this configuration does for us is it lets us use Vite as our dev server locally, and it lets us use this Deno app as our server-side app. It gives us a nice local dev experience. Like Vite gives us hot reloading, all the things that we love about Vite. But in production, the Deno app is what's actually going to be hosting our little editor. So we're going to then update the server-side API with functions which are going to implement the features that we talked about earlier. So we need to get the sample code, we need to deploy the project, and we need to get the deployment. And you'll notice in here, each route is mapped using its verb and its path, followed by the function that is actually going to handle this request. And finally, you will see a route static files from helper that makes sure the React app assets get served correctly in production. So let's actually build out each of these functions now. So a first good example of what a Oak route handler looks like, let's take a look at get sample code. So this is a nice, simple file. All it does is it loads a file from the file system using Deno's file system APIs, and it returns the body in a JSON object. So you can kind of see how Oak works here. You need to assign the response body of the context object provided as a function argument. But let's take a look at something a bit more interesting now. So deploy project TS is what's going to do most of the work of this app. It's what's going to create our new subhosting instances. And when this API is called, the first thing we're going to do is we're going to check, see whether there's an ID that's been passed. We're going to pass this ID as a URL parameter from the Oak router. If we find one, we presume that we already have an existing project that we're updating. If we don't have one, we are going to create a new one. So we'll get it to create a new project for us. Once we've got a valid project ID, regardless of it being new or existing, we're going to work out what content we want to update this project with. So if our API received some code as part of the response body, we're going to use that, assuming that a user has typed in this code. Otherwise, we're going to default to the sample code, which is what will happen when we create a new project from scratch. And then once we've got our project ID and we've got the code, we're going to create a new files map, which is basically just pretending to be a file system, where we give each file uploaded a file name and we give it some content, so some text, some code. But in this example, we're only ever uploading one file, which is going to be our entry point, which is main.ts. We then ask our client to deploy our project, passing the mapped, the files map. And then we return the project, the deployment, and the subsequent deployed URL back to our web UI, which can then be loaded into an iframe. Oh, it's super warm up here. And in order to keep our HTTP API handlers nice and simple, we've created this Deno Subhosting client.ts file, which this is some abridged code here, but all we're doing is we're sending requests to Deno Subhosting API using fetch, which is built into Deno, which is super cool. And each of the functions on the subhosting client represent a Deno API call. We validate our status codes, we add some nice TypeScript definitions to the response object as we return them. So let's talk a little bit about what subhosting actually does. It's a collection of API endpoints that allow you to create projects. These projects can be owned by your organization on Deno Deploy. And you get authentication credentials, which allow you to create as many projects as you like. And you can deploy as many deployments as you like into those projects. And they will each have their own distinct URLs. Projects are, you can think of them as like an organizational unit within Deploy. And deployments share no data between each other, even if they belong to the same project. So we've got extra security there. And if you take a look, I don't know if you can, how clearly you can see the screenshot, but there's some examples of what you can do with each endpoint there. So create deployment, redeploy, get deployment details, that kind of thing. So when you use subhosting, you have an organization. Your organization can contain projects, and projects can contain deployments. And the calls you will make to implement anything that you're building with subhosting are going to be to /organization, /projects, or /deployments, depending on what it is that you want to do. And if you have multiple tenants or you have customers yourself that you want to be selling serverless functions to, you'll be able to capture all of their billing information separately per project, because analytics are treated at a project level. And for the sake of this demo, each sandbox is going to be its own project, with each edit resulting in a fresh deployment with distinct URLs. In a real-world scenario, what you probably want to do is delete older deployments as users make changes, just because it's a bit neater, and you will treat users as a sort of project per user organizational pattern. And for those of you who are interested in what subhosting is actually doing, it's an innovative approach to the idea of shared compute. So Deno deployments are deployed into V8 isolates. Each one gets its own distinct sandbox instance of the V8 engine, which it's going to execute in. And each isolate has access to a virtualized file system and a sandboxed runtime. So each isolate is a completely separate state, has completely separate objects. They can't be used within one another. So again, we're creating that sort of secure environment. On top of that, Deno Subhosting uses 2 VPCs, one for routing incoming requests, and another for isolates to actually access the internet. So you're getting isolation between network traffic, which again, more security. That's what we want, more isolation, more security. So we've built up this project. We're going to deploy it into the cloud with Deno Deploy and test it out. I mentioned earlier, Deno Deploy is very like any other hosting platform that you've used. It's an online tool. It's got GitOps-based CD tools. You've seen all of this before. It's got its own little control panel. And what it does is it creates GitHub actions that will then allow you to update your deployed project every time you make a change. And it's got this step here where you can basically set up a configuration. So what entry point am I going to need? What build tasks am I using? And the important thing that we have to enter here is we do our Deno task build command to make sure this thing is actually going to build. And then what that's going to do is make sure that Vite compiles our React app into the correct location, and it can be served once it's been deployed. And yeah, so our editor has been successfully deployed. And here is one that I deployed earlier. So let us all say a quick prayer to the demo gods. So this is our beautiful interactive sandbox. So here you can see this was our starter code that we gave them in case they haven't entered anything. But obviously we are developers and we want to actually edit the code ourselves. So there we go. So now we see our text input, our text area that we made. And yeah, we can run it, and we've got the response hello world, and we can edit in here. So I could say hello Copenhagen, and I can run it. The Wi-Fi in here is not super duper speedy. There we go. So yeah, we can see that we can run users' code. We can see an output. And this is super cool because we can, as I mentioned earlier, we can do some slightly more complicated things. So this example here is using Deno Serve, which is just a really nice, lightweight HTTP server, which is built into Deno. But what if we wanted to do something a little bit more complicated? What if we wanted to maybe use Oak again and do some more complicated routing? Well, we can absolutely do that. So let's take a look at our Oak example from earlier. So here I am importing Oak directly from JSR. I'm setting up a route just to slash, and if I run this, come on. Hooray, awesome. And we could potentially set this up with a whole load of different routes. At the moment, the demo only allows for slash, but if we wanted to start doing more complicated things, we absolutely could. We can, as you can see, we can import modules that we might need from JSR directly and run them at runtime. Like, this is super cool. We can start to do some really complicated things and actually execute third-party code in a safe and secure environment. And okay, let's swap back. Where is my mouse? There it is. So that was a completely whirlwind introduction to Deno, to deploy, to subhosting, to serverless functions. And the code for this demo is available at GitHub at the above URL. And this is the QR code for the slide deck. So if you want to go through it at a slightly slower pace, it's all in there. All of my speaker notes are in there, so it'll talk you through setting up a project. Deno has some super exciting news coming up in the next couple of months, so keep your ears peeled for that, or come have a chat with me after the talk. I would really love to hear about how you're using Deno, if you are using Deno. If you're thinking about using Deno, I'd really love to chat to you. And yeah, thank you so much for listening.